Hey everybody, for this video we will be talking about parallel lines. So first of all we have to know, what are parallel lines? Well, parallel lines, quick definition, kind of a working definition: two lines in a plane. What is a plane? Again, remember, a plane is a flat surface that continues on forever. So two lines in the same flat surface. We're going to use the computer screen as our flat surface, our plane, for this demonstration. But remember, in the real world we have multiple planes, so we would have some times that this would not apply. So parallel lines, two lines in a plane that never intersects. Or we could say that they maintain a constant distance apart. Okay, so that's kind of our brief definition of parallel lines. So what would parallel lines look like? Well, kind of a rough sketch. There's one line, there's another line. So these two lines in a plane, because they're on the same computer screen. Put my arrows on it to show that my lines continue forever. And it looks like, and it's kind of tough to just draw freehand, but it looks like if I measure the distance from here to here, hopefully it's the same as the distance from here to here. And it looks like I might be off a little bit, but that would be the idea of what parallel lines would be, that if this is 2 inches, then down here we would still have a distance of 2 inches. And no matter where I measure that distance between those two lines, it's going to be 2 inches, as long as I measure at a right angle right here, because that's the shortest distance between two parallel lines. Is it has to be at a right angle to one, or actually it ends up being both of those lines, which we'll talk about later on. Okay, so there we've got an idea of what parallel lines are. Well, what happens with parallel lines for us? We've been talking about equations, linear equations. So here's my coordinate system. Let's see if we can make that a little bit bigger. Stretch it out a little bit for us. Okay. And there we go. I'm happy with that. Okay, so let's label, because we always label our axes. So 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, negative 2, negative 3, negative 4, negative 6. Okay, so there we go. So if I've got a line in here, let's just draw some crazy random line. Not anything significant about that line. I just drew some line. That's my first line. Now I want to make a line that's parallel to that. Well, that means that they have to stay the same distance apart. So I'm going to pick a point, just any point, nothing special about this point, but I'm going to put this point right here. And I'm going to say that I want to keep the same distance from my line, my original lines, to make my second line. So that means that it's going to have to go up and over the same amount as my original line in order to keep that same distance. Let's see, it looks like my original line here goes from this point to, let's pick one a little ways away, this point. Looks like it goes up 1, 2, 3, 4, over 1, 2, 3, 4, 5. So it looks like I have a slope of 4 over 5. It goes up 4, right 5. So that means my second line, in order to stay the same distance apart, should move the same amount. So it should go up 4. 1, 2, 3, 4. And it should go right 5. 1, 2, 3, 4, 5. So there's another point on my line. Now you can see I'm going to run out of room for this line. I don't have room to go up another 4, but if I connect, let's make this line blue, these two dots, and extend through, I should be able to see that, in fact, those two lines stay the same distance apart from each other. So that would make those two lines parallel. Well, then I need to go back and I need to ask, well, how did we make that second line to make that parallel? Oh, we used the slope of the first one. And the big idea here is that parallel lines have the same slope. That's the main idea of parallel lines and their equations. So I know that anytime I have two lines that are parallel, they have to have the same slope. But I also know the reverse of that, the converse of that, which says that if two lines have the same slope, they're parallel. Perfect. Big idea. We got the big idea out of the way. Now we can fill in some details. Okay, so let's say I've got a line, y equals negative 3/4 x minus 5. And I want to create a line that is parallel and goes, or has, let's rephrase that, and has a y-intercept of 4. I know the slope because lines are parallel. They have to have the same slope as what my original did. So my new line's going to have that slope. And I know what the y-intercept is. Right there tells me that I know the y-intercept is 4. Perfect. So I can go to slope-intercept form. Y equals mx plus b. And I can say, well, my slope was negative 3/4, same as my first line. Y-intercept is 4. So I have written the equation of a line that is parallel to this line and has a y-intercept of 4. That wasn't so bad at all, was it? Done. Okay. How about this one? Give the equation of a line parallel to y equals 2/3 x minus 5 and goes through the point -2, 6. Okay, so now I've still got a parallel line, but I don't have the y-intercept. So instead, I'm still going to use this slope right there for my original, but I've got this other point, not the y-intercept. So somehow I need to use that. Well, I think back to my forms of my equations, and I remember that one that was called point slope. Point slope was y equals m times x minus x1 plus y1. Oh, m is still slope. So y equals, my slope is 2/3, same as this guy right here. 2/3, parentheses, x minus, plus outside parentheses. Now remember, y1, x1 and y1 were just values from a point. So I'm going to take this point right here, -2 for my x1, 6 for my y1. Let's simplify that a little bit. Y equals 2/3 x plus 2 plus 6. Well, we've successfully got an equation of a line parallel to the one that we were given through the point that we were given, but we might want to simplify that to slope-intercept. So y equals 2/3 x distribute plus 4/3 plus 6 first. Well, 6 first, I can multiply that by 3/3 to get a common denominator with my 4/3. 2/3 x plus 4/3 plus 18/3. And finally, 2/3 x plus 22/3. There's our slope-intercept form of our equation. Okay, so continuing on with this idea, what do I need to do? What else do I need to know? Well, I need to be able to look at two lines and decide if they're parallel or not. So y equals -1/3 x plus 5. Y equals 1/3 x plus 5. Y equals -2/3 x minus 7. Y equals -1/3 x plus 2. So two of these lines are parallel. So I need to think about what I need to look for with parallel lines. So I'm going to look and I'm going to say, well, that one right there has a slope of -1/3. Are there any others that have a slope of -1/3? Oh, right here we have a slope of -1/3. That tells us that those two lines are parallel. This line is parallel to this line. Okay, so one last thing that we might want to review here is if I've got an equation in standard form. Let's say I've got 5x plus 2y equals 8. And I want to compare this to another line to see if they're parallel. The easiest way to do that is to put it in slope-intercept form so we can compare their slopes. So I need to get y by itself. So I'm going to subtract 5x. 2y equals negative 5x plus 8. I'm going to divide by 2. Y equals negative 5 halves x plus 8 divided by 2 is 4. And remember, I have to divide both those terms. And there we go. So now I could take this equation in slope-intercept form and compare its slope to another equation to see if they are indeed parallel.